The Solidity team has been developing YUL as an intermediate language that can compile to both EVM bytecode and EWASM. This bridges the gap between Ethereum 1 and 2 smart contract development. YUL can already be used in Solidity, it is the inline assembly language, but building an entire contract in YUL is harder. There is no environment where you can just try it out. So here comes the Fuel Labs team. They developed YUL Plus, an extension to YUL which brings some very nice things to the table, among which human-readable signatures and event topics. These open the gate to building a proper ABI for the contract and enable you to easily test it. They have their own editor where you can try it out, but I wanted to test YUL Plus in a complete environment that also has a debugger, and Remix has a great debugger. So this is where the YUL Plus Remix plugin comes in. I am using the latest Remix Alpha version. You can load the YUL plugin as a local plugin, and here you can use the Remix Fuel URL or run the client on your machine and use your local URL. If you don't have any contracts to test, you can load one of the examples. This is the YUL Plus contract exposing two functions, one that stores a variable and one that reads it. The contract expects the call data to contain the 4-byte signature of the function that we are calling and optionally a 32-byte argument. And with the YUL Plus memory structs, handling is more convenient. And this is the YUL transpiled code, the bytecode and the opcodes instructions. Now you can go to the deploy section and deploy the contract. But for this, we need to activate a deploy and run plugin. We don't have any constructor argument, so we can leave this empty. And we get the address and the transaction hash. This is the address at which the contract was deployed, and this is the transaction hash of the deployment transaction. And a nice UI to interact with the functions built from the human-readable signatures. Now we can call the get function, and we see the return value is 0. So we'll store a variable here and call the get function again. And now we see that the store variable is 9. Because we are using Remix's API to send transactions, we can take this transaction hash right here and use it in the debugger. So this was the transaction with which we stored the 9 value into the contract. We activate the debugger plugin and paste the hash here and start debugging. Now you can go through the opcodes and see the stack, memory, and storage changes. So this is our call data, composed from the signature of the function that we are calling, the store function, and then the arguments that we passed, which is our 9 value ABI encoded. And now we can follow what happens in the code. For example, this 36 value is pushed to the stack. And we can see it here. And then the 0 values are pushed to the stack also, and we can see them here. And now the call data copy copies the call data at the 0 pointer in memory. And then we can step forward. And we get to these push 4 instructions which contain a 4 bytes value. And we can see that there are only 2. So these are the signatures of the 2 functions that the simple store contract exposes. And now the program is trying to figure out which of these functions has been called. So we are in this switch statement. This first signature that the program is checking, 6057 and so on, is the actual signature that we used. And if you want to verify this for yourself, you can use Remix's terminal and Web3.js. This is the signature for the store function. And this is the value, and it's the same one as here. So let's continue. We enter the function, and we go through some jumps because this nice syntax has some underlying functions. And we arrive at the ssstore opcode, which actually stores our value into the storage. So before passing through this instruction, our storage is empty. And now we can see our value in the storage placed at key 0. So now you have a convenient way to learn, test, and debug Yule Plus contracts and understand how the EVM works.